हेलो एवरीवन, गुड इवनिंग, कैसे हो आप लोग। स्टार्ट करते हैं आज का सेशन। लेट्स स्टार्ट टुडे सेशन इन दिस वंडरफुल सीरीज बाय बायजूस एग्जाम प्रेप फॉर्मूला मेमोरी टेस्ट, एंड वी आर गोइंग टू टेस्ट योर memory that are you able to remember, are you able to recollect the formulas of thermodynamics. Okay, and as we go ahead we will be talking about, basically it's we have modified the questions in terms of formula simply. Okay, so this session is particularly to test that if you are able to recollect the correct formula or not. Okay, so it will be a easy session if you remember the formulas, otherwise you are going to mess with them. Okay, so let's start the session. Before them, a quick announcement. So guys, I have already published this on my Telegram channel. If you have not joined my Telegram channel, join the Telegram channel. This November I am starting for a wonderful series of PK Nag unsolved questions for thermodynamics. You see, this is basically the only thing that you need to do in thermodynamics. Directly you will see questions, in GATE and ESC from PK Nag from thermodynamics. Okay, so first and second, first is Zeroth law and then work and heat transfer, and then eighth is work and heat transfer second part, and then first law for closed system, and then we will go slowly into the topic. We will be solving everything. I will go till applied thermodynamics, entire thermodynamics, PK Nag unsolved questions, and then applied thermodynamics. Okay, so just be with me. And guys, we are also coming up with a very new series that you will see later on. Okay, and guys, this are my app sessions. Okay, so these are quiz like sessions. Whatever is written in white, these are free app sessions. Okay, so for the entire week I have given you, so just go through it and be with me live in these sessions. So we'll be discussing how, we will be discussing each and everything in detail. We will be testing your knowledge because GATE is around the corner. You have to understand it. Still, if you are struggling with formulas, still if you are struggling with concept, then guys, this is not the right, basically you have not prepared the right preparation strategy. Okay, so let's try to figure out these things. Okay, so these are all app sessions. Now just to give you a brief, so this month I will be taking these sessions in app, and if you want to attend these sessions, download the app, as you all know. Okay, download the app, and from 6th of 6 to 7 2021 22 27, so these are all the app sessions that I will be taking. Okay, so download the app. You can scan this QR code, or you can type in this link, or you can directly go. You can see this, below the video there is this link that you can go through, and you can just click on this link. It will be directed to the app. You can download the app. Okay, chalo. And guys, if you are still struggling with your courses, then we have just started GATE crash courses. Okay, I am taking thermodynamics, and I think machine design also going on. Okay, let me know if I am audible or not, guys. Yeah, I am audible, I think. Okay, so hello Maniket, how are you? Am I buffering or what? Good evening Maniket, good evening. Is it audible? Okay, very well. Let's start. ठीक है, तो guys, and we are also starting sessions for GATE 2025 and 26. If you want to prepare for GATE 2025-26, join these batches. Okay, chalo. And as I told you guys, if you are on the app, all the information is already laid out there. You can go through the app, you can see this, all this information there already. Okay, chalo. And if you have not joined my Telegram channel, video stuck हो रहा है क्या? Is it better now? Is it better? ठीक है, let's go ahead. So, if you have not joined my Telegram channel, अभी भी हो रहा है क्या? अब तो I think it's clear, right? चलो, if you have not joined my Telegram channel, join the Telegram channel because that is the only way we can communicate. Okay, so you can scan this QR code or can just search for this name, see my video and join the Telegram channel. Okay, चलो, I think अभी clear है ना? चलो. So guys, as you all know me, I hope that you know me. If not, let me give you a brief introduction about me. I have 6+ years of teaching experience. I have taught for GATE, ESC, PSUs, AE, JEE. Okay, and I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. 3.5 years of industry and research experience I have, and my area of expertise is basic and applied thermodynamics. Let's start the session, guys. Let's start the session with the very first question. Okay, the ratio of specific heat at constant pressure to the specific heat at constant volume, that means gamma value for monoatomic gas is how much? Gamma value of monoatomic gas is how much? Do you remember it? Gamma value for monoatomic gas, quickly. What is the gamma value for monatomic gas? No, that is not correct. That is not correct. Gamma value for monatomic gas is 1.67. No. That is for diatomic gas. That is air basically. Monatomic gas like hydrogen, oxygen, just only one atom. And it is around 1.67. Yani ki A is correct. For diatomic gas is, yes, we know that is correct. Diatomic gas is how much? Diatomic gas is how much? Just now I told you. Diatomic gas is 1.4. Diatomic gas is how much? 1.4. नहीं बाबा, D नहीं है. 1.4. You have to remember this. Why are you forgetting? Every time you take air, you take 1.4. Air is a diatomic gas. For triatomic gas, gamma for triatomic is how much? सी किसका बता रहे हो, इसका या पिछले वाले का? Gamma for triatomic gas is how much? So you have to understand, for monoatomic it is 1.67, diatomic it is 1.4, and for triatomic it is how much? It is, अरे नहीं, वन for triatomic it is 1.33. For triatomic it is 1.33. Monoatomic 1.67. Diatomic 1.4. Triatomic 1.33. Okay, yes, D is correct. Why are you so confused? Yes, 1.3 is the correct answer. Okay, let's move ahead. An ideal gas undergoes an isothermal process between states 1 and 2. The applicable equation, that means ideal gas equation, especially for isothermal process. What is the ideal gas equation for isothermal process? Yes, B is the correct answer. By isothermal is denoted by PV is equals to constant. मतलब P1 V1 is equals to P2 V2. This is for constant volume. This is for adiabatic. Yes or no? चलो नेक्स्ट. चार्ल्स लॉ स्टेट. चार्ल्स लॉ आइडियल गैस इक्वेशन में पढ़ा है हमने. चार्ल्स लॉ क्या बताता है? चार्ल्स लॉ स्टेट. Hari, this is just formula based questions. Okay, these are just formula based questions. Okay, so we are straightforward coming to formulas simply. Okay. Charles law. What does Charles law tell you? Quickly guys, faster, faster. No baba. Charles law tells you at constant pressure and N, at constant pressure and number of moles, volume is directly proportional to temperature. That means V by T is equals to constant. So V1 by T1 is equals to V2 by T2. Yes? Yes? सही है. Next. Which formula is the correct depiction of the slope of adiabatic? Adiabatic का slope. What is adiabatic का slope? Adiabatic slope is given as adiabatic slope is given as quickly guys, how do you give slope of adiabatic curve on PV diagram? Yes. dP by dV is equals to, so slope is what? dP by dV is equals to K minus P by V. Now the value of K is gamma for adiabatic. Gamma for adiabatic. Okay. The general gas equation is given as, ये तो सबको पता है, ये तो everyone knows. General gas equation is given as General gas equation is given as how do you give general gas equation? Yes, PV is equals to MRT. PV is equals to MRT. D. Molar volume is equal to molar volume is equal to how much? Molar volume is equal to yes. Next, move ahead. Molar volume is equal to (22.41 liters). Yes, at normal temperature and pressure. At normal temperature and pressure. The work done in the expansion of a gas volume V1 to V2 under constant pressure. Under constant pressure, work done in constant pressure process. अच्छा, लेट जा रहे हैं क्या? चलो अभी ठीक है मेरे ख्याल से. Work done in the expansion when you are expanding gas from volume V1 to V2 under constant pressure condition. Constant pressure, Baba, constant pressure. कांस्टेंट वॉल्यूम में होता है 0. कांस्टेंट प्रेशर में क्या होता है? D. B is correct, Baba. What is happening? Work done of a closed system is given as P dV. Now pressure is constant 122 dV. So PV2 minus V1. B is correct. For a given system, is heat is denoted by Q and work is denoted by W. The cyclic integral of dQ by dW for a closed system will be cyclic integral of dQ by dW is how much? Positive entropy, pressure या internal energy? For a given statement, if heat is denoted by Q and work is denoted by W, the cyclic integral कितना होता है? Internal energy. Very good. Internal energy. yes. Gas constant R is equal to, gas constant R is equal to, difference between two specific heats. Yes, Cp minus Cv is equals to R. Yes. Change in enthalpy of a system is the heat supplied at Q is equals to dH. कहां होता है? Is it constant pressure, constant temperature, constant volume और constant entropy? Yes, move ahead. Constant volume नहीं होता है, constant entropy. अरे बाबा, it is constant pressure. Constant pressure is dH. Constant volume is du. At constant pressure. Okay. A है A, B नहीं है. Yes. Which gas can attain the highest efficiency for same compression ratio? Which gas can attain the highest efficiency for same compression rise? Efficiency कब होगी? जब वर्क मिनिमम होगा. तो वर्क मिनिमम किसमें मिलेगा? Which process, which gas will give you minimum work? ध्यान रखो, गामा is 1.4, it is 1.67, it is 1.33. किसमें मिलेगा मिनिमम वर्क? मतलब मिनिमम वर्क किसमें देना पड़ेगा हमें कंप्रेशन में? यस यस, डी में, डी में देना पड़ेगा. सो दिस विल बी gamma is equals to 1.67, gamma is equals to 1.4, and this is gamma is equals to 1.33. So this will take minimum work. It requires minimum amount of work. Constant volume process में वर्क कितना होता है? The work done for a constant volume process. Work done in a constant volume process. Work done in a constant volume process. Yes, जीरो होता है. PdV वॉल्यूम कांस्टेंट है, तो दिस इज गॉन. वर्क इज इक्वल्स टू जीरो. यस. In a throttling process with negligible change in potential and kinetic energy. The enthalpies remain constant, the enthalpy does not remain constant, entropy remains constant, pressure remains constant. Throttling process. थ्रोटलिंग में क्या होता है? Enthalpy remains constant, enthalpy does not remain constant, entropy remains constant, pressure remains constant. Yes, enthalpy remains constant. So it is a isoenthalpic expansion. Pressure reduces, लेकिन enthalpy remains constant. It is a isoenthalpic expansion. So enthalpy remains constant. The work extracted from the system is equal to heat provided to the system. Which of the following is true for the energy of the system? Increase in internal energy, that means it is saying कि dq is equals to dw. Now tell, in here increase in internal energy, decrease in internal energy remains constant. Yeah, this process is not possible. Quickly. Yes, internal energy remains constant. क्योंकि क्या होता है, देखो इक्वेशन होती है dq is equals to du plus dw. If internal energy is constant, then du is equals to 0, so dq is equals to dw. Yes, chalo. For what type of process the change in internal energy equal to change in heat transfer? du is equals to dq किसमें होता है? dq is equals to du किसमें होता है? कौन सा प्रोसेस? व्हाट प्रोसेस गिव्स यू dq is equals to du? dq is equals to du कहां मिलता है भैया? यस, वॉल्यूम में वर्क जीरो हो जाएगा and you will get dq is equals to du. Yes. What is the value of cyclic integral of dq minus dw for a process? For a cycle, for a process, when you are doing a process, dq minus dw is negative, positive, unpredictable or zero. क्या होता है? ये नेगेटिव होता है, पॉजिटिव होता है, अनप्रेडिक्टेबल है। जीरो क्यों होगा भैया? अरे फॉर अ प्रोसेस बोल रहा है, साइकिल नहीं बोल रहा है, फॉर अ प्रोसेस, फॉर अ प्रोसेस। फॉर अ प्रोसेस। डी क्यू इज ऑलवेज ग्रेटर देन डी डब्ल्यू। अगर कोई प्रोसेस कराना है और हीट ट्रांसफर दे रहे हो, इफ यू आर सप्लाइंग हीट, then it will never be converted fully into work. That means you have to supply more heat. Heat transferred will be more than work transfer. So if this is more, this term will be positive. Yes, B is correct. B is correct. Understood? Understood this part? For a cycle, it is equals to 0. For a process, it is positive. For a cycle, it is 0. Yes. Okay. For constant dash process, the change in internal energy in a reversible process is equal to heat transferred. ये तो अभी देख लिया हमने, डी है. Let's move ahead. Which equation is correct representation of the process shown below? What is the correct representation of the process shown below? Quickly guys, answer. This one, answer for this one quickly. अरे आंसर बताओ भैया. It is a cycle. It is a cycle, yes. And in a cycle, Q net will be equal to W net. Yes, C is correct. Very good. C is correct. For any gas, एरो की जरूरत नहीं है बाबा, वो तो बाहर होगा तो नेगेटिव हो जाएगा. चलो. फॉर एनी गैस Cp इज इक्वल टू Cv, Cp इज लेस देन Cv, Cp इज ग्रेटर देन Cv. नॉन ऑफ दीज. Yes, Cp is greater than Cv. Very good. And gamma, which is equals to Cp by Cv, is always greater than 1. The heat absorbed or rejected during a polytropic process is given by. During a polytropic process, heat transfer during a polytropic process. कितना होता है हीट ट्रांसफर ड्यूरिंग पॉलीट्रॉपिक प्रोसेस बाबा? Yes, yes, that is correct. Thick skin. बदल दी फटाफट. पॉलीट्रॉपिक प्रोसेस में हीट ट्रांसफर कैसे देते हैं हम? Yes, C is correct. Very good. C is correct. For a process which is non-flow, the first law of thermodynamics states. Yes, yes, very good, Hari, Amar. Next. What is the answer? Very easy question, guys. ये तो absolutely correct. What is the right answer? Next class for what, Hari? अमर नॉन फ्लो पूछा है. नॉन फ्लो क्लोज्ड. जो what you are telling is for open or flow systems. Total heat supplied at constant volume is given as heat supplied at constant volume. थर्मोडायनेमिक्स की 1 नवंबर को है पी के नाग सॉल्व्ड क्वेश्चन, अनसॉल्व्ड क्वेश्चन सीरीज. आई एम टेकिंग 1 and 2 November पी के नाग अनसॉल्व्ड क्वेश्चन सीरीज. So we will start from Zeroth law, then we will go with work and heat transfer, unsolved questions from PK Nag. So you can practice 9 p.m. on YouTube. Okay. Chalo. Yes, D is correct. MCV T2 minus T1. Yes. In an isothermal process, the internal energy increases, decreases, remains constant. I think this to everyone knows. Isothermal temperature is constant. If temperature is constant, internal energy is a function of temperature. So dt is equals to 0. That means du is also equal to 0. Internal energy. अच्छा, दोनों काम एक साथ कर रहे हो तुम. चलो. The area below PV diagram of a non-flow process represents the area below PV diagram for a non-flow process. बताओ फटाफट गाइज, पीवी डायग्राम के नीचे का एरिया क्या देता है हमें? Yes, yes. Gives you work transfer, PDV. PDV. Okay. Heat supplied to the system equals to work done in case of non-flow process carried out. ये तो हो गया शायद, आई थिंक, है ना, आइसोथर्मली. चलो, the expression PDV gives the measure of work done during steady flow, non-flow, open system, any process, any system, any process. इंटीग्रेशन पीडीवी क्या देता है हमें? व्हाट डज इंटीग्रल पीडीवी गिव्स द मेजर ऑफ वर्क डन ड्यूरिंग स्टेडी फ्लो, नॉन फ्लो, ओपन सिस्टम, एनी प्रोसेस, एनी सिस्टम, एनी प्रोसेस. यार क्वेश्चंस तो बहुत हैं, आई कैन शेयर देम, नो प्रॉब्लम. आई हैव सो मेनी क्वेश्चंस. सी वाई सी, अरे वाई सी, why are you saying C? I don't understand. Open system is what? This is open system work. What is closed system or non-flow? PDV is closed or non-flow. This is open flow, steady flow, whatever you want to call it. इतना हल्का क्वेश्चन नहीं बता पा रहे हो? Yes, yes, I'll share. अभी I'll share this PPT anyway, but I'll share later on. A lot of questions I have. I can share with power plant as well. Do not worry about that. Okay. चलो. Which aspect does not pertain to a free expansion process? Free expansion process. What does not happen in a free expansion process? Yes, pressure remains constant. Everything else happens. What? Work done is zero, heat transfer is zero, temperature does not change. but it is an expansion process. Pressure decreases. Pressure does not remain constant. Pressure does not remain constant. Neglecting changes in potential kinetic energies and shaft work during a steady flow process, just अभी बताया steady flow or open system is VDP. Just now we discussed this. चलो, which equation correction represents the steady flow where enthalpy, work and heat are in kilojoule per kg, velocity is in meter per second and gravitational acceleration is in meter per second square. Identify the correct steady flow energy equation. Identify the correct steady flow energy equation. Enthalpy is in kilojoule. A, B, C, everything is there. C is correct. C is correct. Whenever you take enthalpy heat in kilojoule, you take 2000 and 1000 here. Always. I have proved this by taking units of each and every term. Okay? Chalo. For a boiler, steady flow energy equation for a boiler. For a boiler. For a boiler, work transfer is 0. Kinetic energy and potential energy are negligible. So what do you get? How much do you get for boiler? Yes, B is correct. B is correct. Because everything else is neglected. Only heat transfer and enthalpy term will be there. Okay. Chalo. For nozzle, which one is correct? Nozzle, work transfer is 0. Heat transfer is 0. Change in potential energy is equals to 0 for nozzle. Guys, quickly, we have to move faster. In next 10-15 minutes, we have to finish the class. What is the correct equation, yaar? It is A. Only enthalpy. Yes, A is correct. Very good. A is correct. Only A is correct. Okay. Efficiency of a heat engine is given as heat engine efficiency. I know most of you are going to do it wrong. Quickly. Efficiency of heat engine. Most of you are going to do it wrong. Maniket. Hari, it is wrong. It is always network output. Network, not just output. Upon Q in. And net is what? Turbine, यानी कि out minus in by Q in. Or you can say 1 minus Q rejected by Q in. C is correct. C is correct. C. COP of refrigerator. COP of refrigerator is what? COP of refrigerator. So the purpose of refrigerator is to maintain the lower temperature. So it is always what? Yes, D is correct. D is correct. Q lower upon Q higher minus Q lower. COP of heat pump. So you need to write Q in net basically. Then it will be your correct. C is correct. If you write net, I think this is misprinted here. Okay. Chalo. Consider refrigerator. Relationship between COP of refrigerator and heat pump. What is the relationship between COP of refrigerator and COP of heat pump? Relationship between COP of refrigerator and COP of heat pump. What is the relationship? गलत हो गया, गलत हो गया, बी नहीं है. It is COP of heat pump is equals to COP of refrigerator plus 1. This is a main relationship. So from here, COP of refrigerator is equals to COP of heat pump minus 1. That is the correct relationship basically. B is wrong. P is not correct. Okay. Which of the following is true for real thermodynamic cycle? Real thermodynamic cycle. Real thermodynamic cycle. Which one is true? Swapnil, that is not correct. No, 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 no. Cyclic integral of dq by t is always less than equal to 0. That is the true condition. And cyclic integral of dq by t is equals to 0 for reversible cycle, and cyclic integral of dq by t is less than 0 for irreversible or real cycle. That is the condition. And cyclic integral of dq by t greater than 0 is impossible. That is the condition. So which one is true? क्या है आंसर? बी. वेरी गुड. वेरी गुड के लायक तो नहीं हो, बट ठीक है चलो. Impossible cycle. Impossible cycle. Impossible. Yes, greater than 0. Just now we discussed greater than 0. Okay. Chalo. ds is equals to dq by t holds good in case of irreversible process only. Does not depend on the reversibility or irreversibility. All real processes or reversible processes only. So for a process, ds is always greater than equal to dq by t. So if ds is equals to dq by t, means reversible process. ds is greater than dq by t, means irreversible or real process. And ds is less than dq by t, means impossible. process. क्या है आंसर? क्या है आंसर? Yes, reversible process only. Reversible process only. Which of the following equations is true for entropy generation? Entropy generation for irreversible and reversible process. Entropy generation for reversible is equals to 0. Entropy generation for irreversible is always positive. So what can be said? What can be said about this? अरे बी हो गया ना बाबा, इरिवर्सिबल की बड़ी है. यस. Clearly, which equation clearly defines the entropy change during the constant pressure process? Pressure is constant. M kg of gas at P1, V1, temperature T1, and when heated to P2, V2, and T2. So they are saying entropy is constant. P1 is equals to P2. Whenever you talk about gas, you have two equations to calculate entropy. What? CV ln T2 by T1 plus R ln V2 by V1 or CP ln T2 by T1 minus R ln P2 by P1. Now they are saying pressure is constant. They are saying pressure is constant. So if you want, you can write M here, M, 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 M. Yes. So if pressure is constant, that means this goes away. Your ds is equals to this. Yes, very good. Clearly defines the entropy change during a isothermal process. When isothermal process is there. When it is isothermal, then what will you do? Isothermal. Last one or two questions, guys, we are done. So again you can write ds is equals to mcv ln t2 by t1 plus mr ln v2 by v1. Now say temperature is constant, so this will go away. You have ds mr ln v2 by v1. Yes or no? C is correct. Yes, very good. C is correct. Which of the following equation is true for entropy generation? Entropy generation. Always remember this equation that I gave you. So which one is true for entropy generation? Yes, correct. Universe is equals to entropy generation plus surrounding. Best represent the entropy, net entropy change for a irreversible process. For a irreversible process. Guys, just one second. I think the battery is getting low. Okay, let's finish this. Let's finish. Yes, it is greater than 0. Next. I will tell you, Hari, after this class, I will tell you Telegram group. Okay, it is mechanical by Vipin Yadav. Simple. Okay, chalo. Now, change in entropy for a reversible adiabatic process. Reversible adiabatic process. Reversible adiabatic. Hello. But yaar, you have a very long name. Yes, it is 0. Following is incorrect for reversible adiabatic process. Which one is incorrect? Reversible adiabatic means isentropic. Hello, Shrikant. It is isentropic. If it is isentropic means entropy is equals to 0. Change in entropy. Entropy is constant. dq adiabatic means dq is equals to 0 and q is not constant. भाई q तो है ही नहीं, there is no q, there is no q, simple. Okay, चलो, very good. I think it is the last question. So which of the relation represents an irreversible and impossible process? Irreversible and possible, sorry, irreversible and possible. Last question for you. Irreversible and possible. Yes, C is correct. Yes, C is correct. Very good. Yes. So I think we are done, guys, from today's session. And these are the left sessions that are there: industrial engineering, theory of machine, engineering mechanics, HMT, and production. So follow these. Also, guys, this is my schedule for app. So do not forget to join this, okay, for November month. So you can download the app by scanning this QR code or by just clicking on this link that is there in the description section. You will be directed to the app, okay. And this is the workshop by Abhinav Negi sir on 1st of November on for GATE 2025. So do not forget to watch it. So guys, on the app we have so many things going on. Go and download the app. How can you download the app? By scanning this QR code or by clicking on this link. Directly you will be directed there, okay. So do not miss these opportunities that we offer on app, okay. Go and directly join this. Chalo. Steam nozzle, we are doing this quiz. You see this nozzle and diffuser quiz we are doing on app. Steam nozzle we are doing on app, okay. Quiz, okay. Chalo, ठीक है. Let's stop it here and I will see you very soon in one of the next sessions, guys. Again, from 1st of November, from 1st November, then 2nd November, and then later on, mostly on Wednesday and Thursdays, we will have PK Nag unsolved question series. So don't forget to join this on YouTube only, okay. Okay, Shrikant. Yes, I remember that power plant one topic is remaining, okay. I know I will cover this. Anyway, it's a ESC part. I will surely cover it. It just came very busy with other classes right now, but that I know anyway, and I have noted that we will cover it. Do not worry about that. If I have taken the subject, I will cover it. Do not worry about it, okay. Chalo. And that too is covered only very small portion, like half an hour session is left. Half an hour, 45 minutes, we will be able to cover that, okay. Do not worry about it. ठीक है, चलो. So guys, join this PK Nag unsolved question series to have a good grasp on the numerical questions, because you see, you also know this, that in GATE and ESC you will see direct questions from PK Nag. So let's do some unsolved questions so we'll get a better grasp on the topic. ठीक है, चलो. Let's stop here, guys. I will see you very soon in one of the next sessions, and particularly on 1st of November, 9 PM. It is at 9 PM, okay. That is 9 PM, this unsolved series. चलो, ठीक है. Thank you so much. Bye bye. Tata. I'll see you. Good night.